welcome back to my white live streaming. So, I'm sleeping a lot. Oh my god. Okay, now I'm going to black regarding kinematics concepts once again. So I want to make you clear, guys, because we need to determine at least 6 or 5 equations only in the kinematic motions problem. Okay? So the rest you will be able to to play around during your analysis of the problem. Okay, because the problems are not the same. It will be modified from time to time. Okay, the important is you need to understand the basic formulas, right? Oh my god. Okay. So kinematics for motion problems. Okay? Like that. Okay, so first equation you need to remember is at constant speed, at a constant speed, okay? At a constant speed. So if the question would say at a constant speed, what is the time taken from this car to move to another point, or constant speed, what is the final velocity of the ball when it dropped to the ground, something like that, okay? So it's gonna be distance is equals to velocity times time. So now, okay, distance is equals to velocity times time taken to from velocity is equals to distance over time. Okay, so it's gonna be like that, and then you'll be able to have the average velocity. Okay, is equals to final velocity plus initial velocity, right? Divided by 2. This is the average velocity. For example, if you're asked also for the average velocity, okay? And then there is also another velocity, instantaneous velocity. So you have v with underline at the top. It's going to be xf minus x initial over the time. You need to say distance final minus distance initial over time is equals to 3. So this part here is displacement, and then you have it, right? Displacement. Change in position in terms of horizontal distance. Okay? This is at constant speed. If the problem will say like that, at constant speed, like formulas also. So you need to wait for this to resolve even the problem. Okay? And then another thing is you have to know the at constant acceleration. Okay, like that. Sometimes the problem was at a constant acceleration, blah 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 blah, compute the velocity like that. You also wait for these words, constant acceleration. Okay, but if there's nothing like that, try to solve using these formulas also. Okay, then compare to the choices. Okay, A, B, C, D, E, and you get the answer. But sometimes these words also are not mentioned in the problem. Okay, you get the point, and sometimes need changes. Okay, but if these words are coming immediately, then it will be a bonus because you really use these kinds of formulas. Okay, get the point. And then at constant acceleration, we have 4 to consider. One equation, we have the final velocity squared is equals to velocity initial squared plus 2 times the acceleration times d. Okay, like that. In here, the acceleration is really the acceleration in horizontal displacement or horizontal distance, not the vertical. Okay, this is not yet the free fall concept and the projectile and trajectory. But it's just the same, guys. We will also use this, but substitute with g, acceleration due to gravity. If there is the problem, okay? The point of, because this is more on linear. Okay? You get the point. Okay. So question formula number 2, we have the Vf is equals to Vo plus acceleration times time. In respect to time, we're asked by the time, then solve this one with initial velocity and final velocity. Okay? Number 3, we have, okay, distance is equals to initial velocity times time plus 1/2 acceleration t squared, something like that. Ito po mga palangga. So this is the third equation. Okay? What is the number 4? The number 4 will be this one, dv times time, and we need to derive another formula, right? So it's gonna be like distance is equals to the velocity times time. Then at a constant acceleration, guys, your average velocity will be equal to instantaneous velocity. So what is the formula of instantaneous velocity? This one. Okay, then you substitute that one here. Or either this one, you will substitute this one also. It depends on the situation. Okay, actually you can derive two. Okay, so let's first have the two options on equation 2. So substitute the value of v, because v is just equal to instantaneous, right? So it's gonna be like v, okay, is equals to vf plus vo divided by 2 times time. Then we're gonna say distance is equals to 1/2 times the final velocity plus vo divided by 2 times, number 2 times time. Okay, this is your another equation, equation number 4. And the equation number 5, based on the instantaneous also, we'll substitute here and cancel the time. Then distance is just equal to xf minus xo, displacement. See? Using this one, having your instantaneous velocity is equal to the average velocity. Since this is the value of instantaneous velocity, when you substitute it here, the time will cancel, it will simplify into distance is equals to the final distance minus the initial distance. Like that. Okay? So you have now 6 equations. Okay, like that. Okay? And then what else? Okay, so this one, by the way, mga palangga, kung kita, Vf is equals to Vf is becoming also from, okay, the acceleration is equals to Vf plus Vo divided by 2. And you are just deriving this one. That's why it will become Vf is equals to Vo plus At. Okay, so you have 6 equations at constant acceleration, and we have also 3 equations at constant speed, something like that. Okay, now mga palangga kung hitag, okay, it's gonna be like that. These also equations can be useful in the projectile motion, trajectory motion, but there will be the introduction of 9.81 meter per second square, or in metric system, your A will be now the G, okay, 9.81 meter per second square, okay, and 32.2 feet per second squared. So if it is downward, always downward, right? Negative. Okay, downward motion. That's why gravity, acceleration due to gravity. Okay, some books are having 10 round off, but some more of the books, admittedly, 9.81. Okay, to the points, then we like that only, and then you will solve now the rest. Okay. You get the point? And that's it. Any questions so far for this formulas and equations to be used in kinematics and motion, linear motion? Nothing, right? You can comment down below in the comment section. You can share this academic information live streaming or flag, and then you can subscribe to my YT channel. And then you can click the bell notification for some of this episode. See you channel for us. Bye bye, everybody, and come back.